When you think about the North Pole, you likely picture a fixed, permanent landscape of snow and ice, the anchor point our entire world revolves around. But what if I told you that this stability is merely an illusion, and that the North we rely on could suddenly decide to pack its bags and leave? Imagine waking up in a world where South has become North, where your compass points the wrong way, and the digital maps on your phone spiral into total madness. Birds that migrate thousands of miles relying on magnetic fields would lose their way, crashing into buildings or falling into the oceans, utterly lost. It sounds like the plot of a cheap sci-fi movie, but geomagnetic reversals are a scientifically proven reality that has happened hundreds of times before. The real danger, however, isn't just the compass flipping. It is what happens during the process. It is about the shield, the invisible force field that is protecting you right now as you watch this. This magnetosphere is our only guardian against deadly solar radiation, and without it, Earth would turn into an unbearable radioactive hellscape. Scientists predict that during a reversal, the strength of this shield could plummet to just 10%. Imagine being in the middle of a battle and suddenly losing 90% of your armor. Recent studies in 2021 have linked this weakening to climatic disasters, mass extinctions, and the collapse of ancient ecosystems. For us today, this could mean the destruction of satellites, the collapse of power grids, and a technological regression that sends humanity back to the Dark Ages for centuries. But before we panic, we must understand where this field comes from. Why does Earth have one while Mars and Venus do not? The secret lies deep in the abyss, at the very heart of our planet. There sits a colossal engine, a giant dynamo that has been running non-stop for billions of years. Earth's outer core is a raging ocean of liquid iron and nickel, where temperatures reach 6,000 degrees Celsius, as hot as the surface of the sun. This intense heat causes the molten metal to rise and fall in convection currents, just like boiling water in a pot, except here it is liquid iron. Physics gives us a golden rule. Move a conductive metal, and you create a magnetic field. This is exactly how power plants work. Inside Earth, the flow of billions of tons of iron generates massive electrical currents, which in turn create the magnetic field. But movement alone isn't enough. We need a system to organize these chaotic fields. This is where Earth's rotation and the Coriolis effect come into play. The spinning of the planet forces the liquid iron into spiral shapes, like springs, unifying the smaller fields into one giant, powerful shield. The result is a North Pole, a South Pole, and a protective bubble. It seems like a perfect system, doesn't it? Unfortunately, it is a highly fragile one. Imagine running while carrying a bowl full of water. The water will splash and become turbulent. The same happens to the iron inside Earth. It is constantly sloshing and unstable. These disturbances mean the magnetic pole is never truly fixed. It is a traveler. We have been watching it nervously since 1831. It has left its home in Canada and is now creeping across the Arctic Ocean toward Siberia. But what is truly terrifying is the speed. In the past, it moved slowly, about 16 kilometers a year. Now it has slammed on the gas pedal, reaching speeds of 55 kilometers a year. This acceleration has scientists asking, is this just a casual stroll? Or are we witnessing the beginning of the end for the magnetic stability we've always known? To find the answer, we looked at rocks. When volcanic lava cools, iron atoms inside it freeze, pointing toward the north of that specific moment, like mummified compasses. By studying rock layers through history, we found something shocking. Earth flips its poles repeatedly, 183 times in the last 83 million years. The mathematical average suggests a flip happens every 450,000 years. But the surprise, it has been 750,000 years since the last full reversal. We are living on borrowed time. Statistically, we are vastly overdue for the next flip, and the clock is ticking louder than ever. Yet, nature doesn't care about our schedules. Sometimes 40 million years pass without a flip. and sometimes Earth flips in very short intervals. The current theory is that a disturbance between the mantle and the core breaks the uniformity of the spiral currents, triggering magnetic chaos. A reversal doesn't happen with the push of a button. It is a slow, painful process, where the unified magnetic field begins to disintegrate. Instead of just two poles, the planet might develop 4, 6, or even 8 magnetic poles simultaneously. Imagine a compass trying to work in that mess. During this transition period, known as the excursion, the protective shield weakens terrifyingly, leaving Earth completely exposed to the harshness of space. The beautiful auroras we usually see only in the far north would appear everywhere, in Egypt and Mexico, even at the equator. But this beauty carries death. Excess radiation would cause skin cancer rates to skyrocket and could damage the DNA of living creatures. The most immediate danger is to technology. Our satellites are designed to operate behind a shield. Without it, their electronic circuits would fry, turning them into space junk. Imagine a world without GPS, without satellite communications, without accurate weather forecasting, and most importantly, without stable electricity. Solar storms would hit Earth's power grids directly, potentially blowing out transformers and leaving millions in total darkness for years. But what about the past? Did this cause extinctions? A study from the University of New South Wales linked a similar event to the extinction of Australia's giant megafauna. The La Chance event, 42,000 years ago, was a temporary reversal that coincided with severe climate shifts and the disappearance of Neanderthals in Europe. Is extinction inevitable? Fortunately, the evidence is mixed. Many reversals have passed peacefully without wiping out life. Life is resilient and adaptable. Humans would find ways to protect themselves, perhaps by living underground or developing new shielding for cities. However, there's a worrying piece of evidence staring us in the face right now. A region in the Atlantic Ocean called the South Atlantic Anomaly, stretching from Brazil to Africa. In this area, the magnetic field is already critically weak. It acts like a hole in Earth's armor, and it is growing every year. It is so dangerous that the Hubble telescope has to shut down its sensitive instruments when passing over it to avoid frying its circuits. Astronauts on the International Space Station report seeing strange flashes of light when they close their eyes in this region, caused by cosmic rays penetrating their retinas. Scientists believe this anomaly might be the spark, the starting point for the next great global reversal. If this is true, we are already watching it begin. Earth's overall magnetic field has weakened by 9% in the last 200 years. This continuous decline, combined with the racing North Pole and the expanding Atlantic Anomaly, are all puzzle pieces forming one frightening picture. However, geological time is incredibly slow compared to human lives. A full reversal could take anywhere from 1,000 to 10,000 years to complete. This means we won't wake up tomorrow to find the sky on fire. The process will be gradual enough for future generations to adapt to the new reality. Perhaps we will develop technology that isn't affected by magnetism or build smart shielded power grids. The human mind thrives in crises. The atmosphere itself remains our final line of defense. Even if the magnetosphere vanishes, the thick air above us will stop most deadly radiation. The story of magnetic reversal reminds us of an important truth. Earth is a living, breathing, changing entity, never static. Ultimately, we must remember that we are merely passengers on a massive, complex spaceship called Earth. We are still just trying to read the instruction manual, desperate to understand the secrets hidden deep within our planet. So, the next time you hold a compass and watch that tiny needle swing, take a moment to remember the colossal, silent forces churning beneath your feet. These are the forces that protect us, yet they remain unpredictable. The question haunts us. Will we be ready when 0 hour finally arrives? Or will the very technology we rely on today be our undoing tomorrow? I want to hear your thoughts on this. Share your theories in the comments below. The discussion about our planet's future starts with you. If you enjoyed this scientific journey, don't forget to like, subscribe, and hit the bell icon to ensure you catch every new mystery of the universe. I am Moha, and these were the secrets of the invisible fields. Stay safe, and see you in the next mystery soon.